that people you care about are expected to have. Okay. Anybody have any questions about this?
How much percentage of the remittances go to close family members versus like extended family or grandparents or people who are less genetically tied to?
Good question. It's a good question, and we'll talk about the one piece of research that has been done to directly test the effective inclusive fitness weighted by the reproductive value of the people you're giving stuff to on remittances that people send. We'll talk about it. And it turns out that, at least under this model of inclusive fitness investment, it explains only a third of the variance of remittance behavior, which isn't much. If everybody was an inclusive fitness maximizer, and that model is correct, then it should explain a very larger portion of the variance. Okay. Now we're going to collect. How am I doing on time? I'm doing awesome on time. Awesome. We're going to collect cross-cultural data. And we need a source of data, and I suggest a few. The thing I'm going to use for my dissertation is called the Living Standards Measurement Study, and it's published by the World Bank. It's a collection of, it's more than 85 surveys. This is just a search I did. It's a collection of a whole crap load of household surveys, okay, from countries all around the world. Within this data set, there's over 60 applicable household surveys that have information about remittances and relationships between people in the household and to the migrant. And they have information about remittances sent both ways. Over 20 countries are represented in the sample, some of which have information about urban versus rural people. There's longitudinal data available for some, not enough countries, to perform some of the analyses I'd like to do. So what are we going to do? You not notice that I skipped step 2. Anybody notice that? What was step 2? Develop the models, yeah. We'll talk about that in a second. We've got to test the models that we developed, which I haven't talked about yet. So the first thing we're going to do is we're going to fit the model, statistically, wow, oh my God, that's embarrassing. Fit the models for each social context. How well do the models fit in each of these contexts? Then, once you've answered that question, you're going to estimate the connection between the estimated importance of remittances to access to adequate nutrition and shelter and how well the models fit. And if there's a positive relationship, then you've identified an intervening variable that might account for variation in the adaptive nature of remittance behavior. What about these models? Where are we going to get them from? I already talked about we're going to get them from broad evolutionary theory. But there's a more specific sector of evolutionary theory called comparative social evolution. The answers really, well, ask and sometimes answer really awesome questions like why do genes get together to form DNA and RNA molecules? Why do they cooperate and do that? Why do genes and the DNA molecules that they create bundle up together and collect themselves into genomes? And why does the genome produce different types of cells that interact with one another and cooperate to form or to create bodies? How do bodies in some species collect together like this slime mold does to create a superorganism? How do people like us, how and why do we get together to form kin groups and social alliances? Why is it those hometown associations get together and pool their resources and donate them, right? We're going to focus on these because this is a really freaking hard question to answer. Another question is, once we figure out why cooperation got off the ground, why it's maintained, so why doesn't non-cooperation invade and take over, we got to figure out how should the pie, the benefits of cooperation, be split between members of a group, whether they cooperate or don't, but particularly if they cooperate, if we assume cooperation got off the ground. And then we got to think, okay, everybody participates in a market. You don't just interact randomly with people. You choose your friends. You choose your mates. I certainly did. And, well, she chose me. And she was the aggressive one. And thankfully. So how are people going to allocate their cooperative investments across the individuals with whom they interact? And how are they going to choose who they want to interact with in the first place? Of course, with humans, we can't, well, some people say humans get together to form superorganisms in an abstract, analogical way. But we're really interested in how kin groups form, why they stay together, why they're as big as they are or as small as they are, why do social alliances form between people who are unrelated, and why do different levels of population aggregation, like clans, and villages, and polities, and the UN get together and not do much. And of course, we're interested in cooperative benefits and allocation of cooperative investments. So the key issue in social evolution, some people think, is that is that cooperation involves an altruistic investment. An investment that is, at least in the short term, costly to me, beneficial to you if I'm an altruist. And I am, because I'm cool. Or I'm a sucker. So this is a payoff matrix, which just gives you the payoff that I get if I defect, I don't cooperate, and my partner defects, and same thing, cooperate, blah, blah, blah. Yeah. Okay, so this is how the social dilemma works. I think, if we both ratted each other out, if we both defected, and we're pieces of crap, we would do worse than if we both cooperated. But I'm tempted to defect, because this guy, he might be a sucker and cooperate, in which case I don't pay the cost of altruism, and I get it there, I still benefit from it. And I definitely don't want to be a sucker, because cooperation is costly. So that means that I would rather defect than be a sucker. What do you think is the outcome of this one-shot payoff matrix between people who don't care about each other? They both defect. That's the Nash equilibrium. What's that? What did you think it was?
I think they would both cooperate.
We're very optimistic. I like it. They would cooperate if we shifted the payoff matrix around a little bit. The reason why they won't is because this is the best thing that I can do given what he does. And that's also the best thing that he can do given what I do. Okay? And that's called the Nash equilibrium. It's when people's best responses are the best response to the other person's best response. Okay? In a group of n individuals, if there's a social dilemma, I'm playing n-1 social dilemma games. Okay? And the result is that everybody defects. Okay? And this is, of course, in a one-shot interaction where nobody cares about each other. Okay? How do we get cooperation off the ground? Well, the very general answer, is that we have to make the probability that cooperators, or people who are cooperating at the time, assort with other cooperators more than they assort with other defectors, and vice versa for defectors. Okay? So it's positive. We have to get a mechanism for positive assortment. How are we going to do this? Well, there's a bunch of different mechanisms, but the main thing is that it's harder to do with bigger groups. But there are a few mechanisms. I'll talk about two of them. One of which is, broadly, reciprocity. Reciprocity could involve simple, you scratch your back, or you scratch my back, and I'll scratch yours next time around, right? And so this gets people to cooperate, because if there's a tit-for-tat sort of thing going on, then people will only cooperate with people who cooperated with them in the past. Okay? And then there's indirect reciprocity, where what you do when interacting with somebody else, defect or cooperate with them, depends on information that you have about what they've done from a third party. And then there's negative reciprocity, or basically punishment. You punish people for defecting, and there's no social dilemma involved in punishment. So you don't have to be an altruist in order to punish. Then you can secure cooperation. So there's a whole bunch of problems with this, though. But for these two, they're vulnerable to errors, whether in implementation, how do I behave? So I might screw up. They're vulnerable to perception. I might think that, I'm sorry, what's your name again?
Josh.
Josh. I might think Josh defected when in fact he cooperated. Okay, so if those errors happen, then problems ensue. Another issue is that it's just as likely, so a population of conditional cooperators can't be invaded by a population of unconditional defectors. But a population of unconditional defectors